topic is the main topic is empirical formula for molecular formula, and other topic is balancing a chemical equation, mass percent, what is mass percent, what is the molarity and how to calculate it, and what is the definition of the molality. First we'll start with the empirical formula for molecular formula. So an empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula will be the exact number of the constituent atoms in a compound. This is the difference between empirical formula and molecular formula also. So, if the mass percent of the various elements in a compound is known, then empirical formula you can determine. And in addition, if you know the molar mass also, then you can find the molecular formula also. With this problem, we'll see what will be its empirical formula and what is the molecular formula of this compound. This compound contains the 24.27% carbon, 4.07% hydrogen, 71.65% chlorine, and its molar mass 98.96 gram. So we have to find out what is the empirical formula and what is the molecular formula. So first step, conversion of the mass percent in grams. You consider that the compound is the 100 grams. In this case, it is very simple that carbon will be the 24.27 gram, hydrogen will be the 4.07 gram, and chlorine will be the 71.65 gram. Now convert into number moles of each element. So if we know that if weight of the element divided by its atomic mass, then you will find the number of moles. So it is written there that divide the mass obtained above, whatever the mass we find, then with the respective mass of the various elements, then we will get the number of moles. And in this case, the mole of carbons is the 24.27 gram divided by the 12.01 gram. So result will be the moles is the 2.021, and for the hydrogen, the moles is the 4.07 gram divided by its atomic mass 1.008 gram, and the result will be the 4.04. And the same way for the moles of the chlorine is its weight 71.65 gram and divided by its atomic mass 35.453 gram, and result will be the 2.021. Now what we have to do that here you can find what is the smallest number. Here you can see this 2.021. So we have to divide all moles by 2.021. So it is written there. So in this way you can find that it is, in this case, carbon will be the 1 and hydrogen is the 2 and chlorine will be the 1. If you divide by each case 2.021. Then for the carbon, it is the 1, for hydrogen, it is the 2, and for the chlorine, it will be the 1. So in this way, now we can write the empirical formula using the symbol of the atoms. So in this case, the 1:1 ratio, so 1 carbon to H and 1 Cl, and then CH to Cl is the empirical formula of our compound. But when we have to count to the molecular formula, then we have to consider this, and then how we will find you see that for CH2Cl, the empirical formula mass will be this is the 12.01 and 2 multiplied by 1008, and Cl is the 35.453. So it will be, if you sum and multiply, then 49.48 grams. So if the molar mass is divided by this empirical formula mass, then you will get the number, which with that number you have to multiply this the empirical formula to get the final molecular formulas. So here you can see same way, and then in this case the N is equal to 2. And then if you multiply CH2Cl with 2, then your final molecular formula will be C2H4Cl2. So now you know what is the empirical formula and what is the molecular formula, and how to calculate from the percent of elements present in a compound with its molecular mass value. Now, balancing of a chemical equation we will discuss. According to the law of the conservation of mass, a balanced chemical equation has the same number of atoms of each element in both sides. That means in equation it has left side, right side, and both sides the number of atoms will be same. Many chemical equations can be balanced by trial and error method. So we'll see one example here, that 4Fe in solid form, small s written there is a solid form in bracket, first bracket, and 3O2 in gaseous form, and then the product will be 2Fe2O3, and it is a balanced equation. If you see, here is the 4 iron atoms is there, and in left side and right side also you see 2 multiplied by 2, that means 4 Fe atom also there in right side. And in same way, if you see for the reactant left side, the 3 molecule of oxygen, that means oxygen atom is 6, 3 multiplied by 2, and then right side also you can see the oxygen atom 2 multiplied by this 3, 6. So it is the balanced equation. In same way, if you see that 2 Mg plus O2 will convert to 2 MgO, this is also a balanced equation, because left side the 2 Mg atoms is there, right side also 2 Mg, and left side 1 molecule is there, oxygen, that means 2 atoms is there, and right side also 2 atoms is there. So this is also a balanced equation. But for the P4 in solid form, phosphorus, and then it reacts with the oxygen O2, then product will be the P4O10. And in this case, if you see that for phosphorus the number of atoms in both sides is the same, but for oxygen left side is the O2 and right side is the O10. So this is not balanced in respect of oxygen atoms. So it is the unbalanced equation. So for this unbalanced equation, what you have to do in this equation, phosphorus atoms are balanced, but not the oxygen atoms, what we already discussed now. To balance it, we have to do the coefficient. Here you have to put coefficient to balance with this. So this is O, oxygen atom is 10, and left side the oxygen atom is 2. So 2 multiplied by 5, if you put, then the right side, it will be balanced with the O10. So here you have to put one coefficient before the O2 for the reactant left side, then it will be balanced equation. This is the example of how to balance an unbalanced equation. Now we'll find out what is the mass percent. It is obtained by using the following relation. Mass percent is equal to mass of solute multiplied by 100 divided by the mass of the solution. Problem. We can work out a problem. A solution is prepared by adding the 2 grams of substance. This substance is the solute in 18 grams of water. That means solution weight will be the 18 plus 2. Because here the solute is this substance A and water is the solvent. So to calculate the mass of the solution, then solutes amount and solvents amount 18, you have to sum. You have to add both. And in this case, if you find that result will be, ultimately it will be that 10%. 2 gram by 2 plus 18 by 2 by 20 multiplied by 100, then it is a 10%. In this way, in the easy way, we calculate the mass percent in a solution. Now, mole fraction. It is the ratio of number of moles of a particular component to the total number of moles of the solution. In the previous case, we considered the weight in respect of mass percent to calculate. But for mole fraction, we have to consider that the mole of the solute and total number of moles in solution. So, mole fraction of A, that means number of mole fraction of A divided by the number of moles fraction of solution. And in this case, if you see the solutes mole is the Na and solvents mole is the Nb. So, solutions total number of moles is Na plus Nb. And then Na by Na plus Nb. And in respect of B, if you consider the B, to find the mole fraction, then the number of moles of B divided by the same Na plus Nb. In this way, we can calculate the mole fraction of each component in a solution. Now, molarity. We'll give one example of this. It is most widely used unit and denoted by the capital M. We have to remember this. Molarity denoted by the capital M. And we'll find now after this slide, we'll get the molality. Molality always symbolized by the small m. So that is the difference between molarity and molality. We have to find this distinction. So the molarity, in this case, molarity is defined as the number of moles of solutes in 1 liter of solution. Thus, the molarity is the number of moles of solute divided by volume of solution in liters. Suppose example, we have 1 molar solution of a substance, say sodium hydroxide, NaOH. Then we want to prepare a 0.2 molar solution from it. So 1 molar of NaOH solution means, as per the definition of molarity, 1 mole of NaOH compound present in 1 liter of solution. And for the 0.2 molar solution, what does it mean? That 0.2 mole of NaH compounds dissolved in 1 liter of solution. Hence, for making the 0.2 molar solution from 1 molar solution, we have to take the volume of the 1 molar NaH solution which contains the 0.2 mole of NaOH and dilute with water in 1 liter. So in this way, we can prepare the 0.2 molar solution of NaOH from the 1 molar. Now, how much volume of concentrate 1 molar NaOH solution be taken which contain the 0.2 mole of NaOH can be calculated as such that 1 mole, if you consider the 1 molar of NaOH, that means the 1 mole of NaOH compound is present in 1 liter or 1000 ml of solution. So the thing is that then 0.2 mole is present in the 1000 divided by 1 whole multiplied by the 0.2 mole. So ultimately result will be the 200 ml of the solution, 1 molar NaOH solution required to get the final NaOH solution of 0.2 molar. So the 200 ml of 1 molar NaOH is taken and enough water is added to dilute it to get the 1 liter of the final solution. Now we can use this calculation also, this equation general formula M1 multiplied V1 is equal to M2 multiplied V2. The general formula comes from the previous calculation, where the M and V are the molarity and volume respectively can be used. So in this case, M1 is the 0.2 molar, V1 is the 1000 ml, and M2 is the 1.0 molar, and V2 we have to determine in respect of ml. So if you use this formula, then simply 0.2 m multiplied by 1000 ml is equal to 1.0 m multiplied by V2. So in this way, if you calculate, then ultimately V2 is equal to 200 ml. So we can use this general formula to find the molarity in a solution. So here you have to note that the number of moles of solute was the 0.2 in 200 ml, and it has remained the same 0.2 even after the dilution, as we have changed just the amount of the solvent water and have not done anything with respect to the NaOH. And keep in mind this concentration. Now molality. Molality is defined by the number of moles present in 1 kg of the solvent, and it is symbolized by the small m. Thus, 1 molarity is equal to number of moles of solute mass of solvent in kg. That means in weight of the solvent.